Understanding forecast errors, DP. The forecast error process is found at the end of the demand planning process as part of release demand. Prerequisites. Manage lags 1.4.1. Release demand 1.4. Understand how the inputs are populated. For example, consensus demand forecast error uses consensus demand and sales order quantity. What? Forecast error compares two inputs to see how different they were. For example, consensus demand quantity snap versus sales order history, consensus demand no promo quantity versus sales order history, and stat forecast quantity custom 1 through 10 versus the sales order quantity. The basic calculation is the total absolute error divided by the average of the input key figures. Quiz. If your consensus demand was 120, but your sales order quantity for the same period was only 100, what is the forecast error? Here's the calculation again. Here are the inputs again. The absolute error, or the numerator, would be 20. The denominator is the average of the input key figures, and it would be 110, which is 100 plus 120 divided by 2. So the consensus demand error would be 18%. Good, that's the simplified calculation. It gets a little tougher later. Where? Like most IBP key figures, the error key figures are accessible in charts and dashboards, as well as the Excel add-in. Hint, you can search for error to find the key figures. When? The error calculation is in real time, so it does not require any jobs to run, but you may have to wait for the lags or sales order quantity to show up. If you skipped lags and came straight here, that might not have made any sense. Quickest answer, it takes 10 weeks for a 10-week lag to show up in the current week. If that still doesn't make any sense, see the Understanding Lags video. Why? Very interesting things you can do with errors once you know how they work. Number 1, react to performance issues. See how the consensus demand error was trending down from 90% to 50%, but then it spiked up to 70%? That's bad. 2, react to statistical forecasting issues. Same chart, just added the statistical forecast error. See how the statistical forecast error is getting worse relative to the consensus demand error? 3, compare forecast value add. The delta between the two errors represents how much the demand planner is making the forecast better or worse. This is the same chart, just switch to the demand error for the no promo error. 4, find root cause source of error. This chart shows the consensus demand error by strategic customer, sorted from largest to smallest customer. So the largest customer, Walmart, has a relatively good forecast error at approximately 40%, while the next largest customer, Amazon, is more than double that, probably worth looking at to improve this, whereas a customer that has a high error but no sales is probably not worth your time. This chart segments the consensus demand error into ABC and XYZ, telling you what the error was. Here we can see that our performance is worse for Y items than Z items, 60 versus 62%, and B items are forecasting better than A items for Y items, 62 versus 30%. In general, you want your X items to be better and your A items to be better. 6, slice and dice error by any attribute. In addition to strategic customer, you can slice and dice this error by any product, location, and or ship to customer attribute. 7, including lags. Since this error uses the snapshot key figure, you can compare the error from any lags. The error is also weighted. If IBP just did a simple average, then you would probably see an overall error of 110%. But the top customer, representing 70% of sales, was below 40% error, so the fair overall error is more like 60%. 9, compare weighted to non-weighted error. This is the consensus demand error compared to the key figure consensus demand snap, divided by sales order quantity. When there is a big difference between the two, weighted versus non-weighted, it can indicate a combination that needs more attention. How? You may have noticed something odd in the very first chart we looked at. Do you see how the error goes down from one week to the next? Yet the difference between the two input key figures, consensus demand and sales order quantity, seem much greater in the second week that had a lower overall error. The key word is overall. This chart is at an aggregated level, in this case the entire business unit. So if you really want to trust and understand the error calculation, then you need to understand how the calculation works at the base planning level. For this calculation, there are 3 critical steps that we must perform in order to generate an accurate error value. First, calculate a prop factor. Second, calculate error at the month product location level. Third, assign error proportionally. Let's do a story problem. Nicole and Tom are demand planners for the same products, A and B. Yes, your business might have one planner for each product. Just play along. They just service 2 different locations. Location 100 for Nicole and location 200 for Tom. This is their demand forecast for the month of October. Notice that Tom, who is responsible for location 200, did not have any demand forecasted there for these customers. Fast forward a few weeks or months, and this is what the actual sales were. And since we now know the sales, we can determine how good or bad our original consensus demand was. This is just the absolute total error or the difference between the consensus demand and the sales order quantity at a very detailed week, product, location, ship to level. In fact, it's way too detailed. Let's look at it again. This is at a week, product, location, ship to customer level. Too detailed for a demand planner. They wouldn't care about ship to, maybe strategic customer. Too detailed for a supply planner. They wouldn't care about customer at all. But this level of detail will be useful in a little bit, so don't forget about it. Okay, so if week, product, location, ship to customer is too detailed, what is the appropriate level to calculate an error at? So the first critical design decision, many companies decide the appropriate level is month, product, location. Or another way of saying it, if we sell 20 units less than we thought in 1 week, and we sold 20 units more in the following week, then our supply chain is not going to implode. Same for customers. If Walmart store 3214 orders 20 less in a week than we thought, but Target store 4523 orders 20 more, then our supply chain is still not going to implode. They basically cancel each other out. So back to our example. We don't care too much about this. But we do care about this, the difference between our demand and sales at a month, product, location level. And let's take a moment to look at this example in a little more detail. Tom totally missed his forecast for product A. Nicole for product B was spot on. Nicole was lucky since she overforecasted in 2 weeks, but then underforecasted by the same amount in the next 2 weeks. So calculating an error at month prod loc is better or easier than at week prod loc cust. But that causes some issues. Back to our example. Remember where Tom totally missed his forecast? Although he missed it for both customers, he was 10 times worse for W200 than O200. So assuming that Tom does not have an unlimited amount of time to track down all his errors, where should he focus his time? Customer O200, where he missed demand for 80 in a month, or customer W200, where he missed a demand for 800 in a month? Probably that last one. But unfortunately, we already decided that we want to calculate the error at month prod loc. If only there was a way that I could take that month prod loc error and disaggregate it down to the customer level. Or even better, if there was a way to disaggregate that month prod loc error to the week prod loc cust error. Since week prod loc cust is the level that pretty much all of our demand planning data is at. Huh. How would you do that? It's easiest to see in this example since Tom totally missed his forecast. The total monthly error, 880, matches the sum of the individual week prod loc cust error. So I can proportion Tom's 880 into week prod loc cust buckets. We can even do it for Nicole's example, where she hit the demand to the penny. In other words, she had no error. But it's not as simple for Nicole's other example, where she did have an error, but the total weekly error was higher than the monthly error, which is normally the case. Here, we just need to use the detailed week prod loc cust error to proportionally allocate the month prod loc error. Or another way of saying it, I have 20 points of error that I need to allocate, so it's going to the week prod loc cust combos that had the most error. It's the only fair way of doing it. So this is where you want to pause and hit rewind. Moving on without understanding those last few slides won't be helpful. Now that we have a realistic, fair, and proportional total error at the week prod loc cust level, we can calculate the rest of the percentage error. Remember this? We just did this. So we just need this. So this is the denominator, which is just the average of the demand and sales. And this is the full calculation, TE3 divided by denominator. And if you aggregate it at another level in a query, in this case, month prod. So back to this. We just did it. This is TE1, the detailed calculation at week prod loc cust. This is TE2, the higher level calculation at month prod loc. This is TE3, the lower level value at week prod loc cust that came from month prod loc. And one more thing to keep in mind. The number one rule of demand planning is your forecast is always going to be wrong. It's just a question of how wrong were you and where you can improve. So using forecast error just to say how bad you were is kind of pointless. Your forecast error should tell you where to start looking. So getting back to our example, if it's Tom, I would first want to know my total error, which would be 168%, which is a totally useless number. Okay, so I'm at 168%. How do I make it better? If I drilled down to product, I'd get 200% for A and 9% for B. So assuming A and B are equally important, he should probably look at A first. And if he drilled down to customer, he would quickly realize that he should spend his time with W200. Because if he just had a 20% error on product A, customer W200, his overall error would go from 168% to 44%. So bottom line, Forecast error should be the start of your week to focus your efforts, not the end of it.